what is the next evolution of the DevOps engineer's role? Because it will go away. These agents will eventually replace all of the DevOps, right?
There's always a need for automation and DevOps engineers. That there's a higher demand than what has been taken up, basically, because there's always something you can improve. So part of that is, you don't necessarily remove a bunch of people. You just get things done much quicker. And you take all those easy wins and you deliver them within a couple of months. And delivering something within a couple of months in a large sort of regulated financial services organization is very, very difficult. So anything we can do to take that and really reduce the delivery time, I think benefits everyone across the stack.
Hi, everybody, and welcome to another episode of So What About AI Agents? Today I'm talking to Scott Rowlandson, founder of NetOrca, a network automation platform based in London. Scott recently launched something called NetOrca's Pack, an agentic AI layer which sits on top of their existing automation platform. What caught my attention is that these agents don't just generate configs, they also verify them independently and create like self-healing loops when deployments fail. So this is Agentic DevOps, the next generation of agents that monitor our infrastructure layers. And, this is production infrastructure automation with multi-agent orchestration.
Yeah, well, I think I should first give you a little bit of a description of the platform so you know where we're coming from. Because NetOrca is it's a declarative service catalog, so it allows service owners within an organization to define a service to consumers within the organization, and they can consume instances of that via a Git repository or some sort of declarative way where they own sort of each instance. So what we're starting from is a base where we have really well-defined inputs and really well-defined services, because we've gone through that service owner-consumer relationship. And then normally what you do with our platform and various other automation platforms is you'd then get some consultants to build Ansible, Terraform, Python scripts to take that declarative input and put it onto devices. And that's where we saw the opportunity to say, well, AI agents are getting really good now. Can they do that directly? So can you get rid of or remove the need for spending a lot of time to build those scripts, to build those environments, to deploy those scripts, and say, can we just cut out the middleman there and use AI agents? And that's where we came about the NetOrca Pack.
Yeah, I think during our pre-interview, we were talking about that Ansible and Terraform are basically getting superseded by agents because they used to be abstractions that you had to use to simplify this process, but agents don't require that degree of simplification.
Yeah, I think there's a few other podcasts where they're saying those abstraction layers are dead or dying or discussing that. And yeah, traditionally that's why those things exist. Ansible is a layer on top of APIs to make it easy for you to consume a developer's, a vendor's API. So it's that abstraction layer to say, oh, it's well documented. You want to do something, use the Ansible playbook to go off and do that. And then when you've got LLMs that can understand how to do it directly, so they're almost like an expert for that vendor equipment, then you don't quite need those same abstraction layers, or alternatively use them in a different way. So the good thing about Ansible and Terraform is they offer a controlled way of doing changes on all these platforms, but you don't necessarily need to use them for everything. You can use LLMs for generation verification and then use those platforms to deploy things.
So it sounds like they're still there. It's just maybe because they still solve a lot of the same problems, and it simplifies agents' work. And if you have to write a lot of agentic scripts, agents tend to hallucinate and fail a lot. So we were talking about your orchestrations, right? So can you walk us through the architecture of how you've created these agents and how do they currently work?
Yeah, so I mean, it'll loop back to what we were just talking about as well, because the architecture we created was, so for every customer intent, we have sort of a declarative input that they want X, and these are the inputs that they want. And then off the back of that, we can trigger agents, and we do it in basically our standard now is a config, verification, and execution loop. And each stage of that can have a different LLM with slightly different context. So we work on the base of this is what the customer wants, and this is the bounds on which that should be delivered. But then the config, you might say, can you generate the infrastructure config to deliver that customer intent? The verify is a completely independent LLM with potentially different contexts to say, given the customer intent and the config, can you independently verify that and give me a risk, or even write a change, procedure that could be documented as this is going to be the change. And then the execute part can be another LLM that's triggered. At the moment, we're doing the execute part by grabbing that information and in a script and putting it onto the devices and then getting back the result. So if the config and verify propose a change, let's say a JSON config, we spit it to the A, and then if that fails, we get that result back and we put it into the execute LLM to then analyze why that failed. And then when you get a failure, what you can then do is re-trigger the loop. So when we re-trigger the loop, or the next iteration of the loop gets all the context of the previous failure. So it can say config was this, verify was this, the execution failed because 404 error, it was the wrong API endpoint or whatever. And then it gets that as history and context for the next loop. And that's where you can create the real self-healing thing. So basically creating that, you can create the self-healing, which, in my experimenting, the first question that came out of this is, can it actually create all that configs? Are LLMs good enough? The answer is yes, they are. For even the most complicated vendor solutions, they can. But they don't do it first time. And I think the concept where we've created here is it's not about getting it first time completely perfectly correct. It's about giving the LLMs the opportunity to almost build their own context until they get it right. And that's where the self-healing loop part of it comes in.
Well, it almost sounds like every DevOps engineer, they never get it right the first time. They have to iterate like 5 to 10 times before they get it right.
And that's exactly that's the approach I've taken with this, because I really take that approach of treating AI agents like people in some way, because exactly what you're saying, if you're a DevOps engineer and you're trying to deploy something to AWS, you never get it correct first time. Like no one ever does that. So what happens is you try something on an API, you get a failure, you write in the wrong command, you take that bit of feedback loop and you correct it and you try something else. So that's exactly it. You're trying to create that same architecture that we've all been using for many years to go off and do complex stuff.
So what are some of the most complex things you managed to automate, and what were like some of the challenges that you faced?
Yeah, so we work a lot with, and we've done a bit of association with F5, which is a big load balancing vendor, and they have very specific proprietary config. And so a lot of our demos involved quite complex deployments on that. And they also have quite limited, they have documentation online, but it's kind of hidden under a paywall, so the LLMs doesn't have the whole context. So that was where it couldn't accurately, first go always deploy the right config. But then we started to build up the context to say, okay, instead of just giving the LLM, the input, create this F5 configuration, we instead would feed the LLM with the history of the documentation from that vendor and in a concise manner. So building a history to say, here's all the documentation that you would read if you were doing it yourself. Here's what we want. Here's what the vendor specific output is. That increased the accuracy as it went along. And giving that to both the config and the verify elements of it also increases the verify part of it. So that was a bit of a learning there. And then when you take the other part of it, which really increased the accuracy, was specifically using different LLMs for both the config and verify. So using GPT-5, for example, to produce the config, and using Mini or Nano GPT-5 to verify it. And you say, well, the Mini and the Nano they're theoretically dumber, right? But actually that variance gives you a lot more accuracy into the validation, because it kind of takes a different approach. And a lot of this stuff, the validation is not really, it's not about being the smartest thing ever. It's about meticulously going through and finding issues. So those two things, I think, really helped us, get some accuracy going very nicely.
Interesting. And when we talk about managing context, you manage dumping documentation into context. What are some other context management techniques that you learned? You mentioned using different models to kind of enhance the output and build like a more favorable loop. But regarding the actual context and management of the context, have you come up with any creative ways to basically compact it, to manage it, or like what were some of the findings that you got there?
So a good example of this in my experimentation, doing quite complex infrastructure configuration. The first round I did an example and we did like 50 loops until it fixed itself, right? And then it had a tendency to, because we give each loop the history of the previous loop, you have a tendency to create, one loop will create a mistake, and then the next loop will try something different and that'll fail. And then the next loop will go back to the loop 2 loops ago, basically. So it gets into this sort of mistake oscillation where it doesn't quite fix it. And so your first thought is to just like, well, we'll send it all 50 loops result every time. But if you do that, your context just gets massive and actually you're repeating the same thing over and over again. So the solution to that is there's a couple of solutions that we're working on. One of them is to just record failures separately. So if you get an API failure, create a new list in the context and just say, hey, LLM, you've tried this before and you failed, so don't try it again, basically. So instead of just dumping it all, create a nice, elegant list to say, this is what you've tried and failed, don't try it again. And the other way we're experimenting with is getting an optimizer LLM going on top of all the loops to say, look at all these loops that have happened before, because obviously we have multiple different services providing, and they each have loops. It's saying, well, okay, if you looked across the whole broad spectrum of all these loops that are run, what can you pull out to take that from 50 loops down to 2 effectively? And those combination of things is all about reducing the context or manipulating the context. So you still get the accuracy. So it's not, 200,000 tokens, but you get it to learn from its errors much more efficiently.
It makes perfect sense. So really have like a separate context manager almost. I mean, we're building something on our end where we have like, we build like our own context manager LLM that feeds other agents the context, because we figured if you just have it do like the standard agentic approach where it just pushes everything into that chat and you throw it, it's expensive and it just gets a lot of unnecessary context. So having it pull out pieces of context and store it for reference point and have access to it as a tool call gave us a lot more accuracy on our generation, for example. But in your case, what you're saying is that you're building it as you're going along and you're sanitizing it. Is that what I'm hearing?
Sanitizing it and reducing it. Like that error log is saying, don't just give a dump of every error. Specifically say you called this endpoint and you got this error. So bring in it's almost a token efficient way of saying, this is what you did. You don't need to print the whole error. So a stupid way of doing that would be, if you hit a 404 endpoint on an API, you just get a big dump, like you get a big debug dump. Now, the dumb way would just be to take the whole debug dump, throw it back in the context. But then you've given your LLMs like a whole bunch of, I don't know, Django or React debug that's completely outside what it actually needs to do. And it's sort of messing around with the next loop. So instead, your script or whatever's deploying that should manipulate that to basically this endpoint 404 bad. That's the real token efficient way of doing it. Don't try again. So yeah, that's the type of manipulation we've found successful. Yeah.
So what were some of the most impressive things you were able to orchestrate with this? So what are some of the things that are live in production now? And what are you most proud of?
So I think in our customers, we work a lot of financial services customers. So the things that are actually live in production are using the validates and not necessarily deploying the config. So what we're doing is we had existing stuff where we're building the config, and often you'd have a manual change approver that would go for a config that's generated, manually verify that and approve the change. And the thing we're getting going now, which I'm proud of because it really saves engineer time straight away, is to say, we'll get that independent LLM to verify that. So we're actually using the config and the validate LLMs to verify that script created config. And then you have 2 independent validations of that. And that's a way that we're using it now in enterprise to then build up confidence to then say, well, maybe we'll just get the LLM to build the config itself. We don't need those scripts anymore. So that's a really good way we're using it now. And then impressive wise, because we've been experimenting a lot with our partners here, and just the ability that you can use the loop. So one demo I'm doing with F5, who I mentioned before, is we're trying to work with their distributed cloud platform to deploy load balancers. And so load balancer that's in front of our app. Now, one of the problems they had is you'd have an application that has an open API spec. It says all the endpoints it has available. They want to take that from the application and upload it to their distributed cloud platform. What we're actually using is the AI agents do one loop, and they have the intelligence to this. They'll do a loop and request a retrigger of the loop, and they'll go and get the open API specification from the application, so the target application. They'll save that in context, and then the next loop, they'll go and put it onto the device. So it's the really impressive stuff is getting LLMs to know that they're going to be re-triggered on a future loop and almost like prepare their context for that future loop. And then when we've done that, you're probably thinking as well that the possibilities become a bit endless, because you can kind of, feed a whole bunch of agents in the future with the right information for them to do various different things.
It's almost like reusable context. Is that what you're implying?
It's not, well, it's the LLMs figuring out that they need more context and then getting that in one loop and then using that in the next loop effectively. So yeah, exactly. So first loop, I get information from A, B, and C. The next loop, I use that information to send it to D. But the important thing there is the LLMs are figuring out how to do that themselves. I'm not giving it instructions explicitly to say call A, then call B, then call C. So yeah, I think exploring that now is really impressive.
Yeah, I love when it fails and then it says, well, let me think why I failed. Well, let me just try and do it the other way. And you're like, well, you didn't program it to do it. It naturally tries to be helpful and it tries to go and figure it out step by step. And that's when it fixes itself and it fixes your customers' problems itself. But from what I'm hearing from you, this is not yet so it's hard to build trust for enterprise clients to deploy the self-configs. So what are some of the objections that you hear from them? And what's some of the things that you said they've agreed to, like LLM verification, but not necessarily to LLMs managing the end-to-end orchestration just yet?
Yeah, well, I think that's part of our process to build the trust is what I was talking about before. Using the validation part of it to validate the config that's being manually script generated right now. And then what we'll also do is get the config to generate a comparison config. So the config layer will have a script and the config LLM, and then we build up history as customer requests come through. And then we have a historical comparison that we create there. So we can build trust. Always, I've been working in automation a long time now. And always one of the ways you build trust in automation or anything is to do it a number of times in a live environment. And then once people can see that the config being generated is accurate, and then they start to, trust it basically, because you can point to 1,000 previous runs that generated the exact same as what the script does. But then people would then say, and the objection would be, well, why don't we just write a script for that? Well, the problem with scripts is you have to maintain them. When you need to do a new sort of service or you need to change it, you need to go into the Ansible play or Terraform play in the script. You need to rebuild it. You need to change it. You need to test it. You need to go through all that process. The bit that LLM generated config brings in is you can adapt to those changes. Your vendor changes APIs. You just change, your prompt will almost automatically adapt to that. Whereas traditionally, especially in these large environments, you'd be paying a developer, a couple of months or a couple of sprints time to fix and test all of that. So that's the long-term benefit that we potentially create when it gets exciting as well.
Yeah, I mean, once you build enough of that trust, and you can reduce reliance on the staff. So what are some of so coming back to the people, so did you have to hire more people to help you build this? And what about the workforce reduction? Because many people are scared that this is taking away jobs and people are scared they're going to get laid off. How do people, I guess, transition? What is the next evolution of the DevOps engineer's role? Because it will go away. These agents will eventually replace all of the DevOps, right? So what will be the next step? Where do they go? What do they learn?
I think one answer of that is in enterprise. I'm not seeing, that there's always a need for automation and DevOps engineers. That there's a higher demand than what has been taken up, basically, because there's always something you can improve. So part of that is, you don't necessarily remove a bunch of people. You just get things done much quicker. And you take all those easy wins and you deliver them within a couple of months. And delivering something within a couple of months in a large sort of regulated financial services organization is very, very difficult. So anything we can do to take that and really reduce the delivery time, I think benefits everyone across the stack. The existing DevOps engineers don't have to deal with, automation of quite simple things that take a really long time. They can go off and do even better things, and the customers get that benefit. And if the customers within the organization get that benefit quickly, it actually releases funding to go and build more automation or improve the DevOps life environment itself. So I think that's one effect. I think The other effect, and what we see in network engineering and the area that I started specifically, there's been a big transition from traditional network engineers, like the people who logged onto Cisco devices, switch and typed in the CLI, trying to transition them to a developer, like a DevOps developer, has been very difficult, and it's taking a long time for people to make that change. I think this agentic stuff really, it skips a few elements of that change. You no longer need to go from a network guy to a developer. You can go from a network who has all this ingrained knowledge on how network and shared infrastructure works, to utilize the agents as your sort of developer assistant, to then move into that software DevOps, GitOps way of doing things. So I think from that perspective, it will actually help a lot of people make the transition to automation.
I see. Yeah, I guess, and it's going to help them clean up a lot of the technical debt from all those bad scripts they've been writing for years, in a sense. Yeah, to your point, at a large enterprise scale, they would have really complex infrastructure, and no single LLM will have access to all that infrastructure. So the only thing that they could potentially automate is some script writing and potentially deployments and other things, but it wouldn't be like an agent. Would you see an agent ever having control, let's say, like of an entire banking infrastructure or visibility into that? Because I know it's hard to get it for an individual even. I don't know who would have that level of even access, right? Because of all the security and compliance requirements.
Yeah, a big thing is change management within those environments. So, what we've worked along, if you want to deploy something to prod, you can't just do it straight away in these environments. You need to do it after hours. The scope of the change needs to be determined. So I don't see that going away anytime soon, especially in regulated environments, because if something ever goes wrong, the first thing they're going to go through is, where was your change control? Where was your testing? That kind of thing. But within those enterprises, that change layer is a huge burden. Like, it's a huge amount of the role. So creating a change onto an environment, you need to have an independent person who's checking that. And often it's 2 or 3. So when we talk about roles, you might get the junior engineer who creates a scope of the change that they're going to push. But then you have a couple of very senior engineers that are supposed to go through that scope line by line and approve it. And what happens in large organizations is everyone gets a bit lazy when they're doing that for the 100th time. And so until something goes wrong, you don't go back to that and look at the whole process. And I think that's where I see the LLMs really in that generation, checking, slowing that, or massively speeding up that change creation lifecycle. And then, like we said before, once you've done 1,000 changes in that sort of within that regulated environment and following all those regulated processes, if you've done 1,000 of them successfully using LLMs, then you're going to see a transition to say, well, maybe we can do prod changes at lunchtime instead of 6 p.m. And maybe we can do it every hour now. And that's going to come, but it's probably 2 or 3 years away.
Interesting. So you mentioned a bit about compliance and audit logging. So I can imagine at enterprise level, compliance and audits are like super important. So how do you handle your logging and your like compliance when you're working with your agents? Like is there any specific things that you figured out how to optimize it or make it more efficient? Because I'm guessing everybody who's building enterprise agents needs to be doing that anyways.
So, I mean, we had an advantage for that because it's a GitOps-based platform and we're trying to build services into Git. So what we've also done is built the prompt and context layer into Git. So the base prompt that someone creates onto the NetOrca app, they do that in a Git repository and then they can edit it from there. And so what happens is, because I think, prompt is going to be the new config. You normally put config into Git because you want to protect how people change that. I think prompts in agents are going to be that thing that you need to protect. If you've tested the prompt works for a certain model in a UAT or test environment, you're not going to want everyone to just come in and change them without any testing. So that's why we do that for the GitOps methodology. And then on the platform itself, we log every prompt, every model that's used, and every output of it. And it's important to log that every loop. And so one advantage that it gives for us is you have full audit trail of everything that's done at every time. So you have what comes in as a customer change. So what the customer wanted from the declaration side of things, what the prompt was coming from the Git repo, what the base prompt was, what all the context was, what was the output, and what was tried to execute. And we log all of those pipelines. So from an auditability point of view, you can see any change on any pipeline tied to any consumer declaration change. And then the second, the add-on advantage that gives you is you're creating data to make your agents more efficient through that audit trail. Because like I said before, you can go back through all those previous loops and find out what was inefficient or what didn't work. So I think that's a key part of actually creating systems that'll use agents in enterprise now. What people have done and what MCP got popular a bit is just letting agents directly communicate with things without kind of that logging and governance around it. And that's what I think we're trying to change and what will change.
Yeah, I think governance and how agents get certified is something that people haven't truly figured out yet, just because this is so new. There are some compliance certifications for agents, and they're trying to come up with stuff. But I had somebody on recently, and he mentioned that they still don't know how they're going to regulate it or how they're going to actually determine like who in the end is responsible, you or the agent. It's always you, but it would be good if we could shift some of that responsibility over to the agents. Now, regarding the future, you mentioned something like 2020, like in like 2 years, we're going to see some big changes and big shifts. So what are some of the things that you see will come out of this tech? And what are some of the shifts that you see on the meta level of DevOps?
I think one is the speed of change and continuous deployment is going to change, because you can have LLMs that meet all those compliance requirements quickly within minutes rather than, hours and days that happen now. So your frequency of pushing change is going to increase in enterprise a lot. And then for me, what that gets me thinking on the future is and another factor of that is LLMs are just becoming so cheap to do, even huge context stuff right now. So what that becomes for me is like, why don't you just run it all the time then? So why don't you have like NetOrca pack loops running for every config element in every environment 24/7? Because what that then gives you is a future where you have continuous config reconciliation versus a state. So, and you have your constant deployment of customer changes. So, you have a load balancer that has two servers that it's pointing to. The customer doesn't want a server, they take it out, continuously deployed somewhat. But then on the reconciliation part of that is you have a core piece of infrastructure. Some NOC engineer comes in, accidentally deletes something. It gets deployed straight away based on the LLM being triggered. So I think we're getting to the scenario where they're so good and so cheap, then why wouldn't you do that? Because you have a direct, you can say, I'm going to spend $10,000 a month on reconciliation, and that just translates to an amount of tokens, and you can see how many times you want to run that. So yeah, I think that would be an interesting future state.
So really, agents monitoring us and fixing our mistakes proactively without us having to do anything. Well, we still have.
Yeah, I think when you bound the infrastructure deployment on the input, then it's easy to keep reconciling that state. So I think the work we need to do now is to really, this is what I've done foundationally for automation, is to bound what it is you're actually deploying. I think the thing that won't happen is just you have an agent where you just give it a really vague scope, like deploy me this infrastructure, and it just goes off and constantly does that, because the problem is it's limited in what it knows you want. I think if you have very specific sort of, like we do, declarative inputs and structured way of deploying it, then you could say, I'm going to continuously reconcile that because I know it will always deliver the correct piece of infrastructure. And it also gives you a bounds on which to test that, because you can tell the agent that there should always be a load balancer available for this service, right? If you can tell it that, then it knows what to fix. If it's the entire banking app should always be up, then there's too many factors for LLMs to monitor and fix. So it's almost like you're creating almost an army that has a specific scope of what they want to look at, and they're the ones that keep that running.
Do you think we're going to start to see more native agentic integrations in platform like Kubernetes, where Kubernetes introduces its own agent that does its own monitoring and fixing of stuff?
I think possibly, but I think one of the things the vendors is maybe missing now is I don't think there's much value in like a Kubernetes trained agent, for example, because every LLM knows how all that works. Yeah. Why pay for the proprietary one when you can just use the general one for it? And A couple of years back, I was thinking, okay, well, the frontier LLMs are going to be too expensive to run for these things. But then, GPT-5 came out a few months ago now, and Mini is amazingly cheap. So, and it's as good as what 4.1 was in terms of its knowledge. So, and they're only going to get cheaper. So you don't need like a super specific trained, very cheap LM, because the frontier ones are cheap themselves. So yeah, I don't know. I think that these things will be released, but their value is yet to be determined.
No, this makes perfect sense. So it's been really valuable. I think people who want to check out NetOrca Pack or connect with you, where should they go? How should they get in touch with you?
Well, they can add me on LinkedIn, so I'm sure we'll put a link in, and they can go to netorca.io. That's our website. There's quite a few things up there, some demos. And yeah, follow me on LinkedIn. I will be releasing more and more demos around this, and I'm having fun experimenting. So I want to share that with everyone.
Yeah, thank you for walking us through this. All this is particularly interesting, especially the way you manage context or set up the self-healing loops. I think it will be valuable to many of the people. Is there anything else you'd like to leave people with? Any kind of thoughts? Any of your future vision or some of the things you're working on?
Well, I think one of the things we're working on now is taking that concept to be as universal as possible, because some of the demos I've done previously were giving quite specific instructions on the output. And one of the demos I'm going to be releasing now is taking that same concept of a loop and just saying, can you give us the API calls and a list of steps to go through to go and achieve something? And when you can do that, you can apply it to anything. We could build up a whole AWS environment. We could build Azure, multi-cloud stuff. So I think that's interesting. That's something I'll post soon. And I think the message for people is, these things are a lot more capable than people are giving them credit for. And when you give them bounds and when you're smart about your context, and context in both the giving it the right information, but not giving it information that it doesn't need as well, I think is a key insight, then you'll be really surprised what you can achieve with it accurately.
Amazing. Well, everybody, this is Scott Rowlandson from NetOrca. Feel free to reach out to him, and thank you so much for tuning in.
Thank you.
Scott.